Good afternoon and welcome to this Chemistry World webinar. I'm Ben Valsler, Chemistry World's digital editor, and while people are still joining the webinar, let me just take you through the platform that we've chosen to use and how you can use it to engage with today's speakers and make sure that you get the most out of today's experience. Now, we're using GoToWebinar, which you will probably see as a strip down one side of your screen. You should also see the screen that we're sharing that will have the presentation on, and you can probably also see my face in the webcams box. If you're on a slow connection or if you're having any problems like that, you can switch off the webcams with a button just above my face right now, but you'll still be able to hear us and see what's being shared on the screen, so you still get all the experience that you need just without the beautiful faces on the front. The other key thing about GoToWebinar is that it allows you to ask questions. Now, usually down at the bottom of that GoToWebinar panel, you'll see a chat or questions box where you can ask a question of the organisers. I can see already that Sandeep has used that as an opportunity to say hello. So hello, Sandeep, and thank you for joining us. But if there's any questions that occur to you at any point throughout the webinar, then just pop them in that box and we'll be able to put them to our speaker after the presentation. Now, we may run out of time to get through all of those questions, but that's no reason to not put a question in. We keep a record of all of the questions along with your contact details. So if there's something that we can do to help after the webinar, then we will do our best to get in touch. So get your questions in at the bottom of your GoToWebinar panel in the questions box. We're also asking a few polls throughout the course of today's webinar. Those are a really good opportunity for us to get to know a bit more about what you know, a bit more about who you are, and a bit more about your understanding of the topic that we're approaching today. So when those polls pop up on the screen, do please give us your opinion, give us the answer that you think is correct, and it really does help us. Likewise, there will be an exit poll when you finish the webinar where we've got a couple of questions just to help us make sure that the webinars are delivering exactly what you need them to deliver. Also, after the webinar, in a couple of days' time, we'll send you a link to the recording in case you missed any parts of it or just wanted to go back and pick up on some of those details again. And we'll also send those of you who attend live a certificate of attendance, and that's our way of saying thank you for joining us. So keep an eye out in your inbox in a few days' time for those things to come through once we've had a chance to process them. Now, moving on to the topic of today's webinar. So today we're looking at the Circular Economy Data Challenge. Now, what we intend to do is gain a deeper understanding of the chemistry-focused data challenges that exist in commercial circular economies. Now, circularity extends the lifetime value of chemicals, but also introduces new challenges in ensuring product safety and quality. So in this webinar, we'll explore how a generation of tools will be required to track chemicals throughout their now extended circular lifespans. Over the course of the next hour, you should have identified data requirements that pair with chemical requirements for circular systems. You should gain a specific understanding of regulatory and quality challenges faced in using a circular chemical process, and you should have developed insight into the types of software solutions that can be adopted to meet these data challenges. So that's all coming up over the course of the next hour. Now, we have worked very closely with Viva to identify this as a topic that we know is of interest and relevance to chemists working today, and they have put us in touch with Andrew Douglas. Now, Andrew is strategy lead for chemical industry for Viva Systems, got more than 20 years experience in R&D and marketing within the chemical, biotech and consumer goods industries. He's got a PhD and a BSc in chemistry from the University of Southampton in England, so he knows what he's talking about. He's the right person, and we must say a huge thank you to Viva for allowing him to spend his time with us today and to share his expertise with you. So once again, get any questions in, and I can see Andy is very quick off the mark with a couple of great questions in there. We'll do our best to come to those after the presentation. But the next voice you should hear and the next face you should see will be Andrew Douglas. So let's get his camera and mic up, and then we'll hand over control for the presentation, and we'll pop back to you for those polls as we come through, and then we'll take your questions at the end. So thank you again for joining us. Thank you, Andrew, for coming along as well. I think we can hear you now. We can certainly see your screen, not yet see your camera. Let's just make sure that your camera is live, and then I can sit back and enjoy the presentation. Andrew, thank you for joining us. We can see you and see your presentation.
Well, thanks, Ben, and thanks for the kind introduction and for the opportunity to speak. So hello, everyone, and welcome to the Circular Economy Data Challenge. As chemists, we're uniquely aware of the chemistry challenge we face with the circular economy, and my goal today is to help you to understand that there's a complementary challenge to solve, and it's one that is equally daunting, and that is the challenge of data. So let me tell you the thesis. What I believe is that circular economies will drive digital transformation. And the reason for this is that consumers are demanding product transparency, product quality, and product safety. They will expect to know where a product and all its components come from, its provenance, if you like, and they expect that product to be of high quality and safe. And if you think about extending the lifetime of a chemical as it goes through circularity and the complexity of the journey that chemical goes through, that's going to introduce enormous data challenges. So let's think about an analogy. And the analogy I want to share with you is the idea of what happened when e-commerce met marketing. And people went from buying one or two products from a shelf to all of a sudden an infinite shelf, and how consumer goods companies had to radically transform all of their digital tools to deal with this new internet consumer. And what I posit is that in terms of compliance and circularity, we're going to see a similar disruptive shift as people are moving from the old world of exchanging documents up and down supply chains, managing things in Excel spreadsheets. They're going to need connected, smart systems supported by artificial intelligence and the like to be able to manage all of this complexity. So let's just quickly talk about how e-commerce did transfer marketing technology. And if you think about it, one of the big things that happened was, like I said, a grocery store would typically have 2 or 3 choices that you could go and buy. And so for a consumer goods company, the big victory was to convince the buyer of that store product to ensure that they're one of the 2, 3 options on shelf. But internet retail has no such limitations. You can carry hundreds or thousands of options to solve the same need. And so a primary problem became, how does my product get on the front page or even at the top of the first page? And this turned into a technology response called search engine optimization. How can you use the algorithms to get to be found first on an internet search? And this is incredibly complex. Google, for example, I think uses more than 200 attributes on its search algorithm. So it's a very complex data challenge to be findable on the internet. A second one, and this one really blew my mind when I first heard about it, is this concept of real-time marketing. When an ad appears on your internet page, what actually happens is that that ad is transacted and sold between the time you click the button and the page loads. So computers are actually selling ad space real time between your click and your page load, something in like 200 milliseconds, to be able to put that right ad, right time, right in front of you on your internet page. So that they move to real-time ad buys. And third, there was a big need for marketing analytics. People want to know who clicked what. Did they go through? Did they actually move to a transaction inside the checkout box? Did they actually pay the money, check out, and buy the product? Did they come back later and buy another product? All of this has a data requirement. And all of this companies wanted to track. And they've developed a lot of digital tools to be able to achieve this. Excuse me. So what we see in terms of circular economies is that there are some very serious demands that circularity will put on us. One is product traceability. Where did it come from? What happened to it? The second one, as you see, will be flexible sourcing. And the third one is around product safety. And this is going to drive a technology response in creating transparent supply chains, connected product quality systems, and a new wave and a new age of digital regulatory management. So that was my thesis. Now let me just give you a little bit about myself and who is Viva. So who am I? What I would say is I'm obsessed by efficiency. And that's what has really drawn me to digital technology as an enabler throughout my entire chemical career. I started at the University of Southampton, as was mentioned by Ben, and it was a world of notebooks and desktops, right? We really just had word processing on a computer to be able to print out a report or a thesis. When I moved to Syngenta as a formulation chemist, so I developed the chemicals inside products like this OptiGuard that you see, it became a world of isolated databases. We would load formulation data into a single database, but those databases were not connected across the organization. After several years at Syngenta, I moved to Solvay, a B2B company, where we would develop new ingredients, new chemicals that would go inside things like shampoos, toothpastes, baby diapers, baby wipes, etc. And that was where I really got my first exposure to collaboration tools, what we would call e-rooms, where you could start to share information and documents in a communal space, so you could work together. After that, I moved to the Clorox company out in California, and I spent 8 years running open innovation. And we got introduced to the idea of natural language processing analytics. We would go and grab thousands of views off the internet and find out what consumers were saying about products and analyze that, and that would inform new product developments. Or, for example, if you look at this package for the product 409, we also worked on high performance computing to be able to optimize those packages to reduce plastic that is exposed to the world. Then I joined Zymogen, a biotech company here in the Bay Area, and this was what really opened my mind to the power of machine learning. Because at Zymogen, when they're making gene edits and they're genetically modifying organisms to make new chemicals, the machines are much better than the people at designing, executing, and exploring the experimental space. They could do much more. The power of the technology was overwhelming. I now have joined Viva, and now I'm in the world of cloud software. So let me tell you about Viva. So Viva develops software that helps companies to manage product compliance. And what I mean by that is every new product or raw material that a chemical company develops has to be checked that it's safe for consumers, that it's approved for use by governments, and that it always meets quality specifications. And we develop and deploy cloud software for the purpose of this, to make it as easy to be able to manage regulatory affairs as it is to go and find something, a product on Amazon, or to track something in FedEx. So we bring an easy consumer web experience to what is actually a very complex, necessary process inside a chemical company. So now let's talk about chemical circularity and transparency. So circular economies are the path to sustainability. And just for grounding, I've used the definition from the Ellen MacArthur Foundation. If you want to know anything about circularity, it's a wonderful website and a set of resources and an action initiative. It's incredibly powerful. So a circular economy is based on the principles of designing out waste and pollution, keeping products and materials in use, and regenerating natural systems. And what we're doing is we're moving from this transactional linear economy, where things end as waste, into the recycle and reuse and the constant regeneration of chemicals, so that we're not generating waste and we're protecting resources. Now, time for a poll.
Thank you very much, Andrew, and a great introduction to the topic and to your really interesting work experience so far. Let's get the first poll up on the screen, and then we can go through it. And we encourage people to answer this. You may have been sat back enjoying the presentation so far, but we need you to dive in, grab your mouse, and tell us, what do you think? How many metric tons of plastic have been discarded since 1950 over the course of 70 years in our linear economy? So linear being these products are created in a factory somewhere and end up just going straight into the bin, compared to a circular economy where things get recycled, reused, and reabsorbed back into the supply chain in order to save money, reduce waste, and save on raw ingredients. Now I'm looking, so I'm watching the number of people, or the percentage of people who have voted. I can also see a real-time readout of what people think, and it's getting pretty interesting there. There's a clear winner at the moment, and we'll give you a few more seconds to get those last few votes in. So if you haven't voted yet, dive in, grab your mouse. You've got a few seconds left to click, And I think that's probably about enough. So let's share those results as well. So 5 billion was clearly from the outset, that was the biggest one there, 47% of our audience today. But I confess, as we went through, the 500 million mark did start to creep up and erode some of its lead, as 5 billion was well over 50% earlier. But now it seems very few people think we're looking at 500K or 5 million tons. And then as we go up towards 5 billion, there's more people showing a bit more confidence. Andrew, what's the real number, and which of this audience group got it right?
So it's great. In fact, it demonstrates that you have a well-informed audience, because in fact, it is 5 billion, and it's a mind-blowing, mind-numbing number. It's really, whenever I tell people that number, their jaws drop.
It's very hard to picture what that actually means. Really is. Anyway, thank you very much to everybody for completing the poll. Andrew, I shall hand back to you.
So yeah, in fact, the real number is 5 billion. And there was this very nice report built that you may have seen. So in fact, 8 billion has been produced. There are about 2.5 billion tons in current commerce. And some of those are in, short cycle times, like a plastic bottle, and some have long lifespans, for example, in an automobile, where they might last 10, 20 years. But the vast majority has already been discarded. It's quite amazing. And what we're seeing is that waste management is improving, but it's still not nearly enough. Here we have some numbers from Europe on how much they're recycling. So things are moving in the right direction, but they haven't been moving in the right direction at an adequate speed. So now I'd like to open up for a second poll. Ben?
And here we go. Sorry, I was a little slow off the mark to hit my microphone and camera buttons there, but hopefully our audience won't be slow off the mark to respond to the second poll. So, which polymer has the highest mechanical recycling rate in the USA? Now, there's a full list there of things I'm sure you're very familiar with, certainly familiar with their uses, if not their chemical nomenclature. So, polyethylene terephthalate, always a tricky one to say, which is the sort of thing you see in clear plastic bottles. Polyvinyl chloride, PVC, those are the pipes and tubes that you'll see. LDPE, or low density polyethylene, which is the sort of disposable plastic bags that you pick up from a supermarket. Polypropylene or polystyrene, and not just the expanded stuff they use for packaging, but the white plastic cutlery, dinnerware, disposable things like that. Which one do we think is recycled the most in the USA? Once again, I can see the votes coming in, and if you've already voted and you're waiting to see the results, now's a great time to type in any questions that you have. I appreciate when you're watching the presentation, you may not want to be typing, you need to pay attention to make sure you absorb everything. So now is a great opportunity. Get your questions in at the bottom of the GoToWebinar panel. I think we're probably, that's probably about enough time now. A similar number have voted. So let's once again share those results. And this time there's a very, very clear winner, if you'll pardon the pun. It's those clear plastic bottles that are made of polyethylene terephthalate.
And yes, the audience is absolutely correct. That is the most recycled material out of all the plastics.
Excellent. Well, thank you once again for doing the poll.
Yeah. Let's go back to my screen. And those of you who are really on the ball might have noticed that there was a slight error in what I'd given Ben in terms of the definitions, because polystyrene is what you would typically find plastic cutlery and dinnerware to be. So there's about 30% of PET, which is recycled from bottles, and almost nothing else is really recycled. And there's a major challenge in the US at the moment about, the recycling system is kind of collapsed. So it's great that we're seeing some more traction. And just to go one level deeper on this, if you look at how much waste is being generated, or at least the proportions, PET is one of the smaller contributors. LDPE and polypropylene are the major share of plastic waste being generated. And today, they are not recycled. And the recycling that is done today is mechanical recycling. That is the dominant process that exists. And one of the challenges with mechanical recycling is that typically the properties of that plastic degrade as you recycle it. And so the recycling then becomes finite because you keep degrading and eventually you reach a quality which is not sustainable or not reusable, I should say. If we look at where the innovation is going, it's very exciting because chemists are coming to the fore, whether it's through chemical processing, as I show here for PET, or whether it's through biotech processes from where enzymes and genetically modified organisms are being used to find new ways to break down plastics to break them back to the constituent monomers or constituent units. So then they can really truly be reabsorbed in a fully circular manner into the economy. And these are really exciting advances. Still moving forward, there's still a lot of investment and a lot to be discovered, but it's an extremely exciting space and it really holds great promise for the future. And another great thing is that industry momentum is building. In the Plastics Pact, which is related to the Ellen MacArthur Foundation, there are now more than 450 signatories of this Plastic Pact. And what's good is that this represents more than 20% of global plastic use by consumer goods companies. And they have made commitments, various commitments around the world, depending on which pact they've signed up to. But for example, a commitment to 25% plus recycled content by 2025. And that today cannot be achieved just by mechanical recycling. So it's actually pushing the industry to innovate and to drive to better. If you think about circularity, consumers are going to have a lot of questions about it. Some of the key questions they're going to ask is, where's this material coming from? How can I be sure it is safe? What contaminants does it contain? Does it still meet regulatory requirements? And is it of equivalent quality? Because I don't want to make trade-offs. I don't want to downgrade my experience. And these questions are all going to have to be answered. And that is why we're going to see this digital transformation, this drive to transparent supply chains, to digital regulatory, and connected quality. Because today, supply chains are really built for efficiency, as we'll see. So let's keep moving. And now let's talk about the data challenges associated with chemical circularity. So I want to walk you through the supply chain regulatory and quality challenge. So if you think about when a chemical moves from company to company, I have my example here on the left-hand side, propylene glycol, very common chemical used in all kinds of products. When somebody ships a drum or a tank truck of propylene glycol and it gets used in consumer products, they don't just ship the product. There's an enormous amount of information that has to flow along the supply chain with that product. There's the safety data sheet, right? What are the classifications and risks? If I have a spill, what should I do with it? How do I manage emergencies? So there's a set of safety information that is transmitted. There are regulatory data sheets. Where is propylene glycol approved for use and for in which markets? This one in the picture is USP grade, so we know it's okay for medical. But there's a whole set of authorizations. Is it okay in Taiwan? Is it okay in USA? Is it approved for use in Canada? All of these things have to be defined and they have to be communicated all the way along the supply chain. Equally, everybody wants to know whether or not it meets quality requirements. So there's a certificate of analysis that is generated with every single batch produced and is sent with every single batch produced. This is the specification that I've promised to you, and these are the results that I measured on this actual drum to be able to demonstrate that it meets your expectations. And then there's also a document called a raw material questionnaire, which catches every question which is not caught in the other three documents. And these raw material questionnaires today can be about 10 pages long for every chemical. Is it halal? Is it kosher? Is it sustainable palm oil? Is it organic? What organic content does it have? Is it certified? Are there labor conditions that I need to be worried about associated with the manufacture of this material? An enormous amount of sustainability and traceability information. But the thing that you have to understand with this is that the norm today is for all of that information to be shared inside documents. Somebody writes an SDS, they create a PDF, and they send it by email. Somebody collects the email and they try to archive it somewhere in some system. Same for technical data sheets, certificates, or raw material questionnaires. A raw material questionnaire, maybe a Word document, somebody fills it out, and they send back a Word document. So you have this incredibly disconnected, inefficient, and error-prone system where documents are flying left and right, point to point. So maybe BASF sends one to Unilever, and they send one to Procter & Gamble, and they send one to Syngenta, and everybody's doing point-to-point communication. It's incredibly inefficient. It's incredibly open to mistakes. And just imagine what's going to happen when circular economies come in, because, you know, if you think about something like ethylene glycol, it's no longer a situation where you're dealing with very high volume, highly optimized petroleum commodities, where literally, when I worked at Solvay, ethylene oxide for glycols, etc., there would be a pipe literally that came out of the wall of the petroleum factory, the refinery, straight through the wall into our manufacturing site, straight into our batch tanks. It was that optimized. And now we're moving from a world of highly optimized, very high volume chemicals to maybe I'm going to be sourcing my material from all the waste oils that are sitting outside automotive shops or industrial factories. And I have to go and collect that. It's going to break the system because you're going to have so many different sources, but you still have to guarantee quality and safety. So let's just take the journey of ethylene glycol in polyethylene terephthalate, in PET. Okay, ethylene converted to ethylene oxide, to ethylene glycol, that then forms the PET. That is then used by a consumer goods company to make a plastic, right, or a molded product. And at every step of that part of the journey, the material is controlled. You know exactly where it's been. They know how it is handled. They're checking specifications and purity at every step of the way. And they have regulatory approval for every step already in place. The product then, once it leaves the door of the consumer goods company and lands at the retailer, is no longer in a controlled environment. Retailers are not checking quality. It then goes into the consumer use where it's absolutely uncontrolled. Somebody could take a plastic bottle and put brake fluid in it for a year and then throw it away. Who knows what's happening? And then it goes to disposal. If you think about a circular glycol, it has a longer and a more varied life. It still moves into an uncontrolled situation where it moves through retail use or retail supply chains. It then moves into the consumer's hands. The consumers dispose of it, but then it's collected and it has to be reprocessed. And that reprocessed material has to then flow back in to the chain as ethylene glycol. And this is where there's going to be a huge trade-off, because you could reprocess to the exact same quality and the exact same purity that you have with your base ethylene production process, but that may become at a cost. So there's probably some trade-off that's going to have to occur in the world of all recycled materials of how do I define good, how do I define safe, and how do I define equivalent quality, even if I'm not exactly doing what I did because I'm now using a different source. And that's going to introduce a lot of questions and a lot of complexity. Because if you think about it, with these virgin feedstocks, you have very few suppliers. You have very low specification variability. If you buy ethylene oxide, it's the same everywhere. You have very low purity variability. Every ethylene oxide certificate of analysis will define exactly how much water is in there, exactly what else is in there. And you have very low regulatory complexity because it's been approved for 50 years. As you move to circular feedstocks and they move through the value chain in different ways, you're going to see more suppliers, more variability in specification, more variability in purity potentially, and all of that will contribute to much greater regulatory complexity to be able to tell a government agency, yes, I can be 100% certain that this thing is good for consumers to touch and use. Because if you think about it, we still are going to need all of the data and documents to be able to ensure compliance. In Europe, there are more than 200 materials which are restricted. And for any circular chemical, somehow people will have to be able to inform the agency that none of those 200 restricted substances are there. Or there are substances subject to authorization, and people will have to be able to define and communicate that to agencies to give them confidence. If you think about it from a quality point of view, most of the petroleum products are very tight specification, very standardized. And we're going to move to a different kind of supply chain where the raw material specifications could be more varied. You would now have an auditing question because you have more sites. How do you audit more sites? How do you manage complaints if you have more complaints? So we're going to have more data and documents transitioning. And the same for these long raw material supplier questionnaires. They're going to get longer and longer with more and more questions because there's more history that one has to communicate. So what does the future look like? What do solutions look like? And I'll just walk you through some solutions of today and solutions of tomorrow that we could imagine. So the first step that companies are taking is that they're unifying data and documents. And what I mean by that is usually when you walk into a company, you find they have their documents in one place and they have their data in another place. Maybe their data is sitting in an Excel spreadsheet and their documents are sitting on a SharePoint, and they're unable to connect those, which makes it very difficult because companies in that position are unable to get the context around products, to understand the full story of a product. I have a document here, I'm not even sure if it was the right version. I don't know which version I used in my registration, etc. So they have this real issue and challenge of finding information and connecting information. So they're moving to very modern, user-friendly cloud systems to be able to manage data and documents together. Once they've unified their information, there's an enormous unlock because unified solutions enable traceability. So you can imagine, in this case, what I'm showing on the left-hand side, if you walk through, there's a dashboard of chemical registrations at a chemical company. And you can immediately, instantly click into that dashboard and look at all of the registration records. And then you can equally click through the registration records to all of the documents and data that we use to support that registration, which allows you this transparency, this click, click, click transparency from the top to the bottom to, I have 1,000 products around the world to, I used these 7 pieces of information to support my registration of this product. And I know where it came from, what it did, and how it was viewed and how it was assessed. And this is what companies are going to need to set their foundations. The other thing that companies are moving to is instead of living in email or other offline activities or using Outlook calendars to remind themselves when they have to do a task, they're moving all of the tasks into the same unified system. What I'm showing on the left is an example of an automatic workflow laid out, which allows somebody to say, I'm going to start a new process of assessing a chemical. And it immediately sends a request to person A, who does their work, makes a decision. It then goes to person B, who might even be in a different organization, a different company, to do a piece of work. And so then people can collaborate real time inside a single system. The system can tell you when you need to do your work, and what work you need to do. So then you reduce errors, you reduce risk, and you dramatically increase efficiency. And then you can plan and track. So this is what companies are investing in right now, to be able to do this, to be able to move everybody into a unified system so that all of their data and documents and information is collected in one place, which makes it unified, searchable, and traceable. I want to push one step further. And where's circularity going to take us? Because what I just showed you is not enough for circularity. It's enough for today, but it's not enough for circularity. And what I believe, what I posit, is that documents will become data, point-to-point sharing will become exchange networks, and traceability will be the price of entry. And let me tell you what I mean by that. So we live in a world today where we share an enormous amount of documents. And frankly, 99% of the data is locked inside those documents. People are going to look at a document, they're trying to read through it to find out what is the critical information I need. And the future needs to be data, because when you have data, you can work with data. You can cross-reference it, you can check it, you can run tests against it, you can map it, you can report it. And it's very powerful. So think about an example of an SDS. Today, an SDS lands at a loading dock, or lands in an R&D facility, and somebody says, I've got an SDS, a new SDS, I'd better load it in the system, and I put it in the system and forget about it. But there's very critical information inside that SDS. Think about it. For example, the product name, classification. Is it an eye irritant? What other classifications does it have? Ideally, you would want your system to automatically pull that information and digitize it. So extract it for you in an automatic process, then populate it into a set of records for you. So now you have all of the information around that chemical all collected as data. And then you can take it to the next step where you could run an automatic comparison. If somebody gets a new SDS, somebody today has to manually check, have the classifications changed? Because if the classification changed, the risk changed, and now everyone has to do extra work, necessary work, to go and check, did that classification change introduce risk to my manufacturing people or to the final customers for my product? And you can have the system automatically check for that and then automatically set out workflows and send workflows to everyone to solve the downstream problems. So we'll move to a world where documents stop exchanging, or if they are exchanging, the outcome will be data at one end, data at the other end, because data is power. The second thing that will happen is that point-to-point sharing has to transform to network exchanges. And what I mean, I mentioned this earlier, chemical company X, BASF, Solvay, Evonik, right? When I was at Solvay, we would send one set of documents out to one customer, the same documents out to another, a slightly different version to another, and we would do everything is point-to-point communication, which is brutally inefficient. What's going to happen is that data exchanges will evolve in a way that has high security, because this is the challenge. People are asking the question, can I really put my information in a secure environment and control who gets which confidential information or who gets which information which is public? In fact, technically, this is all doable today. This is already in place to be able to have security across every single data field, across a wide range of companies. What isn't there today is the ecosystem for people to work in a single system. If you think about how Microsoft Outlook transformed email, right? Because everybody started working in the same system. And so it was easier to talk to each other in the same system. But my real point is point-to-point sharing will transform to network exchanges. And the third thing is traceability will become the price of entry. I have Clorox disinfecting wipes. It's one of my favorite products. In fact, it is Clorox employees' product that they will give up last. So everybody loves it. But the point about this, if I go to a shelf and I buy a disinfecting wipe from whichever company, I am going to want to know, where did the cap come from? Where did the package come from? Where did the shrink wrap come from? And what was its impact on the environment? What was its carbon footprint? I want to know, where did the non-woven and where did the liquid absorbed onto that non-woven come from? Is it safe for me? How was it developed? Where did it come from? Was it sourced in the right ethical manners? And was it sourced in a sustainable manner? And this is going to become price of entry. All companies at some point are going to have to be able to create transparency and traceability all the way through their supply chains to be able to deliver this information to consumers, so consumers can make informed sustainability choices. So let me just wrap. First point, digital transformation has begun, and we've seen companies move to digital cloud solutions. And here we have Shana from Syngenta. They manage thousands of incredibly complex registrations on pesticides every year. There could be thousands of documents in a single registration. Incredible complexity, all turned into simplicity, where now they can do tasks in seconds that used to take weeks by moving to a well-organized, unified cloud system. And we're entering a very new world. It may not be exactly today or tomorrow, but it's coming, and it's really coming upon us. We're entering a world of new and distributed supply chains, which is going to fundamentally change how we operate as chemists. So back to my thesis. I believe that circular economies will drive digital transformation, just as e-commerce did for marketing, because we need this transparency and compliance. And before we end, just a quick poll for you.
Thank you ever so much, Andrew. Let's get our final poll today before we go to Q&A. Again, another good chance to get your questions typed in while you answer our question. Is your organization ready for circular economy data? So are your systems all ready to go? Do you think you can adapt with incremental digital improvements, changing one system at a time until everything lines up? Or do you think you're right at the very start of the process and you're going to need to transform your systems entirely in order to be ready for that circular economy, handling all of the data that needs to be handled? I'll give you a few more seconds to get your answers in there. And meanwhile, do keep those questions coming in. We've got just over a quarter of an hour for Q&A, which should be plenty of time. I see we've already got some great questions in, so do please keep them coming. And meanwhile, let's just give you a few more seconds to vote in that poll and let us know a bit more about you, and then we will share that. So I think that's probably enough. Let's close it down and share it, and let's have a look at the results. So just 2% say they are already completely ready to go, and perhaps this webinar was not designed for people who've already got all the answers, but it's been really useful for people in the middle bit and the bottom section who are still looking for the answers, looking for the solutions to adopt. So 32% of our audience today can adapt with incremental digital improvements, but a full 67% are at square one with this, and clearly are in the right sort of places, looking for advice, looking for ideas, talking to people like you, Andrew, and engaging with companies like Viva. So thank you ever so much to everybody for completing that poll. Andrew, we'll hand back to you just for the last couple of slides, and then we'll go straight to Q&A.
That's great. And do you see my screen?
Yes, we do.
That's great. And actually, the survey makes a lot of sense, right? Because the future is already here. It's just not evenly distributed. And there are always leaders that are ahead of the game. So that's wonderful to hear that. 2% of you are ahead of the game. I love it. So, and in fact, we are at the end of our talk. And I just want to thank everybody for taking the time to listen to this. It was so much fun to write. It's such an important topic, circular economy. It's a grand challenge for our time, so it's wonderful to be engaging on it. And time for questions.
Thank you very much again, Andrew. And yes, plenty of good questions coming in. But as you can see on the screen now, there are contact details and a URL on there. So if you want to follow up with anything, if you've got a question that you think is probably not ideal for the webinar, maybe it's too specific or too in-depth, contact details are on the screen now, or you can find out more by following the link that you can see. We will also pop the link into the chat, because obviously typing out a URL you can see on screen, not always ideal. If we fire that across in chat, then you'll just be able to click that and land directly onto Viva's website. So let's crack into these questions. Lots of really good questions coming in. Let's start with a fairly general one about the power of data, of proper data management in terms of international collaboration. So Chris pointed out, with reference to our earlier poll, that the recycling rates for PVC pipes and so on are very different in the EU compared to the USA. And I guess the question that stems from that is this another place where properly handling your data is going to be really helpful in dealing with different regions that have different standards, different expectations, and need to have different things reported?
So it's a very good point, and I think the answer is absolutely yes, because if you look at most companies today, companies are trying to do the right thing. They want to make the right sustainability choices. And the thing they're actually struggling with is they don't have the data to make the best informed decisions. And when consumers are asking them, where did this come from? It's not necessarily because they don't want to tell them. It's because they don't know. They don't have the information structured internally in a way that says, I know where this came from, I know where it went, I know how it was used, and I know where it's headed. They just don't have that information today. And what's being forced on them is that they need to take this holistic product stewardship view and have the data ready for people. And that's the transformation.
That sort of feeds into a question that Richard asked as well. He said, this is going to require competitors within different parts of different supply chains to all agree on a standard set of documents, or at least standard set of data within that, and in what order the types of data fit into their systems and so on. He says in his 20 years experience in the industry, he's not seen that sort of coordinated effort. What do you think will need to change for people to start working together in that way?
So it's a really, really good point. I'm actually much more hopeful, and if you look at an SDS, right, an SDS is globally harmonized. We have globally harmonized classifications. It's proven time and again that it is painful and slow work to get those harmonizations to occur globally to the point, but it does happen. And I think what is happening with this coalescence of industry and consumer pressure around plastic management, that will drive standards in a faster way. That's my prediction. But you're absolutely right. You have to be able to translate data across. And I think the highest value data is really where you focus. And that's what we work on at Viva. It's like, what are the most important data points and how can we make those connected across companies? How do we use the right information? Sorry.
Well, I was just thinking the sort of third arm of that. You've got the companies themselves and what they want to achieve. You've got consumer pressure, and then the other aspect is regulation. And you've already mentioned how proper data management can help you to meet regulatory requirements. But Roel has said, is the government up to speed? Are we seeing the regulation keeping pace with the public demands and with corporations want to be able to do, even if they're not certain how?
My own sense is that nobody is up to speed with where consumers really want us to be. And everybody's now trying to fight a rearguard action to catch up. But what I will say to come back to the data and the governments are now moving to data entry systems and not document systems. So the European Union, for example, if you do a REACH registration, that is a data registration. So they have all of the data. And if you go on a website like ECHA, ECHA, you can find all of the toxicity profiles of all of the materials in commerce in Europe, which didn't exist 20 years ago. And in fact, those are all structured around standardized tox templates. So there are areas where we really actually have a much better platform than we had 20 years ago.
Excellent. Thank you for your question, Roll, as well. One from Duncan here. Is there a greater danger of untruthful information getting through and being less easily spotted by the user? I guess the issue here is if we have AI and automated systems and not necessarily a human being doing the interpretation, will things slip through that might be misleading?
Yeah, I think there is a risk. I think our view at the moment is that even if you do an automated compliance, you still need a human view of it because there's nuance and somebody needs to do a ratification. You can't just let the systems do it themselves. I would add one other piece of information because people talk a lot about public debates, and I'll give you an example. We did analysis on, triclosan, which is quite a famous antibacterial in the US, and there was a huge debate about it, and it looked like there was a consumer push that drove the final regulatory decisions and consumer goods company decisions. But actually, we had some analytics tools that let us search back to where all the sources of that debate were coming from. And actually, they're all coming from scientific academics. So it was actually a scientifically driven decision when triclosan was taken out of the market for hand soaps, but kept in the market for toothpaste, for example. So that actually made me very heartened that when you actually tracked all the way back, it was science driven that was actually driving those debates and provable.
We just have a question as well about the ability of researchers to drive change. I didn't catch the name of the Ramin. In fact, thank you, Ramin. I think that's probably answered your question anyway. Let's just pick up a couple. So from very early on, and certainly key to this, you talked about chemical recycling. So we're talking about breaking a polymer back down to its monomers so you can then reuse it, compared to mechanical recycling, which is literally just chipping the plastic, trying to melt it down and make a new bottle from it, and so on. So Pratik was wondering, is that the future of recycling, moving towards a chemical route? Because clearly that will have an impact on the sort of data that you need to hold, because you'll need to know these processes above and beyond literally chopping it up into small tubes.
Yeah, I think that all solutions will be necessary to get us to where we need to be, right? But I do think that if you're watching, and I think everybody on this call certainly is watching where the literature is telling us we're going, and the reports from early stage companies and just the investment flowing into biotech and chemical reprocessing, it tells us that solutions will come, the problems will get solved, things will get better. And so they will become more dominant methodologies over time.
Okay, another question from Chris. There's so many great questions. Do please keep them coming, but they are really good. So Chris said, how do you view the European Chemical Agency, the ECA's substances of concern in products, or SCIP database? Is that similar to the sort of thing that you're proposing here?
So I don't know if I'll answer the question the right way. I mean, the fact that people are clarifying where concerns should lie and shining spotlights on it, being transparent about it, can only be a good thing. Because if you're informed about what you should be managing, you will then focus on it and make the right decisions. So I think my view, I'm not representing the company view, I think, but my view is that this is a great thing. That
Excellent.
Somebody's actually tracking and harmonizing that, because that will, and Europe does drive a lot of, thought leadership and thinking, which then will drive the coalescence of global action.
I guess that's a consequence of having so many different companies in a union like that, where you have to harmonize, so you have to share data, and inevitably we're going to need to do something with that data to really understand it. Speaking of sharing data as well, Alexander says, how do you manage the security of data being shared between collaborating companies, perhaps within a supply chain?
So, I mean, for example, in the system we have, you can control data down to a single field and a single result. You can control security down to like one box.
And so you can specifically control which users will have access to and be able to modify, read, etc. I assume also there's access tracking in there, so you will be able to look back and see who has had this, who has changed it, when did it change, so you can do a full audit of your data processes when you need to.
Yeah, I mean, modern systems like this, you can, even this presentation that I wrote, I have a record of everybody who looked at it, everybody changed it, everybody who put an electronic post-it note on it. You can see everything, every transaction related to the document.
Najendra asked a very similar question as well, so hopefully that will answer your question, Najendra. Let's have a look. Stefan has said, so we're going back to plastic recycling. What do you think is the key driver preventing plastic recycling at the moment? I guess the example I'm aware of is in terms of aluminium. So aluminium was mined, it was mined for a very long time, and then there was a key commercial moment when it became cheaper to recycle aluminium that had been used before than it was to mine it, and that was a huge commercial driver. And so now most of the aluminium that we see in our products that reach our hands is recycled. Where are the drivers going to come from for recycling plastic?
So I think it's the $1 million question. And the economic trade-offs are usually the hardest things for companies to deal with. I do think that there are several things that happen. Consumer pressure drives changes in the market. And I think there's a great analogy. If you think about organic produce, 20 years ago, you could not find organic produce in a grocery store.
No.
It was very niche. It was very expensive. And if you go into a grocery store today, in my grocery store, 20%, 25% of the meat shelf is organic produce or grass-fed produce, for example. And the prices have come down dramatically because now they have critical mass. And it's usually economies of scale that you'll have to get to, right? You need to be able to segregate your processes and drive to economies of scale. So I think that, and that's why it's not going to come today or tomorrow. It might be 15 or 20 years in actual time, but I think it's clear that that's what everyone wants and what consumers are demanding, and then the technology will catch up. But people won't suddenly just say, I'm going to spend twice as much on a product tomorrow.
How do you think companies are going to be able to overcome that initial price hump to get into a circular economy?
So you can see it at multiple levels. I think the simplest way for them to do it is to say that if I can say this is a transparent product and I can say everything about it, there's usually a price incentive because it's preferred as a product to a consumer. So that question is, does it become more valuable to the consumer, and then can I get return for the value the consumer sees? Because it is more valuable to a consumer. And then you get your lead consumers to help fund your transition into the total economy.
So going back to your organic vegetable example, that the people who were happy to pay that little bit more at a farmer's market or an organic vegetable delivery system and so on, they were the ones that then led to the organic veg you now see in your supermarkets and so on. We've got about 3 minutes left. I still need to do thank yous and so on. I'd like to point out as well that my colleagues who run the back end of the Chemistry World webinars, Chris and Francis, they keep everything running smoothly. They've also shared Andrew's email address, so have a look in the chat and go to webinar, you can pick that up. You mentioned the thing about sending documents around by email. Clearly this year in the UK has been a really good example of where relying on an Excel spreadsheet is not necessarily the right thing to do for your data. Why do you think companies haven't already started adopting better tools?
Historically, companies have not seen things like product compliance or regulatory compliance as a valuable business asset. They've spent a lot of money on digital marketing tools so they can get to consumers faster, they can understand consumers faster, so they can increase revenue because it has a very direct impact on revenue. And all those markets are great at asking for funding because they're all trained in how to write a business case. Regulatory professionals are saving the world for us. Our quality professionals are making sure things are safe and compliant, but they've historically been viewed as, hey, it's like I have to have a quality department, I have to have a regulatory department, but they don't really help me. But everybody now realizes that time to market, usually the regulatory path is the determining factor. So now, and we all know first to market wins. So now regulatory is actually being, and product stewardship is being driven to the fore because that is the thing that actually drives your competitive advantage. So there's a mindset change. It hasn't flowed all the way through the economy or the industries, but the lead adopters have clearly understood that, and they've made the shift.
And it can be the difference between a successful product launch and a failed product, just the regulatory approval, meaning you don't get first to market. It can be life or death for a company or for a product.
Absolutely. Absolutely.
Well, I think we've run out of time realistically, but thank you ever so much, Andrew. You've joined us for Chemistry World webinars before, and it's always a pleasure to have you with us. So thank you for making the time to join us again today. Thank you as well to Viva for once again giving up Andrew's time to join us here on the Chemistry World webinar series. Thank you to, as I said, Chris and Francis, who've been running in the background, keeping your questions coming into me. We've also had Nicole Saschetti from Viva, who's also been helping me to marshal all of these questions. And thank you, of course, to you for asking all of those excellent questions, for engaging with those polls, and for really making these webinars what they are, as without the audience there, it would be a fascinating presentation, but it wouldn't be the engagement, and that's what we're looking for. So keep an eye out in your email for a link to the recording if you wanted to watch anything again, and that little thank you, an attendance certificate. That's our way of saying thank you for joining us. You'll find more Chemistry World webinars at chemistryworld.com/webinars. So if there are more events like this you'd like to get involved with, then find them there. And once again, in the survey that you'll be given as you leave, let us know what you thought of this, and feel free to get in touch with any ideas for things that you'd like to know more about that could make a difference for you, your industry, your research, your business, or just your life. I'm Ben Valsler, Chemistry World's digital editor, and I'll see you in the next Chemistry World webinar. Thanks again.